Good afternoon. If you are registered for the overview of IEC standard for low voltage switchgear and control gear assemblies, IEC 61439-1 and IEC 61439-6 webinar, you are in the right place. My name is Patrick Yeo, and I'm the ASEAN Sales Manager for UR Energy, Power Technology, also known as EPT, for ASEAN region, and I will be your moderator for today's webinar. I will also be assisting our presenter, Mr. Chandra Kumar, also known as CK, with some parts of the webinar. I would first like to explain how this webinar will be conducted. You will be listening to the webinar using your computer speakers. You may submit questions at any time during the presentation by typing your questions in the chat panel on the bottom left of the screen and hitting send. We will answer as many questions as time permits. If we do not get to your question, we will follow up with you. Additionally, the webinar is being recorded and a link was sent out in an email. Today's webinar focuses on IEC 61439-1 and IEC 61439-6 overview of IEC standard for low voltage switchgear and control gear assemblies. These two standards play an important role in the services UR provides for evaluating and certifying busways and its associated fittings. Now, I would like to introduce our presenter, CK, Senior Staff Engineer and Asian Regional Lead for Global Market Access. CK has 20 years of experience in standard development, product testing, and certification to national and international standards. 9 years of testing and certification at ISO 17025 accredited 50 kA short circuit lab. CK is a member of BIS National Committee for Low Voltage Switchgear and Control Gear Standards. He is also our distinguished member of technical staff of the William Henry Merrill Society. Now I will turn this presentation over to CK. CK, thank you.
Thank you, Patrick. Ladies and gentlemen, good morning, good afternoon. It's my pleasure to present this webinar. We have a good representation of participants for this webinar from ASEAN, Greater Asia, and other parts of the region, covering all relevant stakeholders in the switchgear and control gear assemblies, including the value chain from manufacturers, designers and consultants, regulators, international sales, and business development staff. I would like to thank one and all for taking your time for this webinar, and we look forward towards an engaging knowledge sharing and clarification on any questions you may have related to today's topic. As Patrick rightly indicated, we are going to talk about the IEC 61439 Part 1, which is the standard for low voltage switchgear and control gear assemblies general rules, and more specifically we will talk about Part 6 standard, which is for the busbar trunking systems. As we all know, the busbar trunking systems play a very vital role in the electrical distribution infrastructure, given the number of high rises, housing, infrastructure, industrial, and hence their product quality, installation, and associated due diligence, including testing and certification, requires due importance to be considered by designers, consultants, manufacturers, regulators, and end users in every market, considering the safety of people and installations. This webinar will broadly cover the following two topics. To start with, we will review the high-level purpose and the role of standards. We will subsequently discuss the IEC standard for switchgear and control gear assemblies, primarily for busways. And finally, we will wrap up with the questions and clarifications that you might have. Okay, so let me first start off with the standards and their importance in the development. Now, before we go any further, you will notice that we have set a limited agenda for this session today, as this is the first part of our three-part webinar series on 61439-6. The other two parts in the webinar series are scheduled in the coming weeks, and we will focus more on testing and certification options, global market access, more specific details of tests like temperature, short circuit. So as such, you might want to consider some of the places I might be brief on the subject. So let us begin with the role of standards, its importance, and how it gets developed. Now, as you can see from this slide, any compliance system typically has multiple elements, of which the three high-level elements have been listed here. As you can see, one is the conformity assessment, which is a program set by the regulators or by the specific country. Then you have the standards and technical requirement, and finally you have enforcement. So as you can see from this slide, it's very clear that the standards and technical requirement form an important element in any compliance system. Now, having said that, what is a compliance system? So a compliance system is nothing but a method by which a region, for example, ASEAN or Europe or North America, or a specific country like Malaysia, Singapore, or Philippines, they determine how the products would be accepted for sale and use within its borders. More so with electrical products, because we have a risk, inherent risk in electrical products. One is a risk of fire, risk of shock, thermal risks, the various associated risks that could arrive because of these products. And now let's talk about the standards, because it is one of the critical part in a compliance system. So as you might be aware, there are very different types of standards available nationally and internationally. At a very broad level, we could classify them as system standards and product standards. Now again, under product standards, you could have product specific standards, or you could have generic standards. So in this webinar, we will primarily focus on product standards that are applicable for busways. Now, having told that, what is the definition of a standard? Now, a standard is a document. This is the definition from IEC. Is a document established by consensus. That's very important. Why do we spend so much time in talking about standards? Is because by the time the standard is published, there's a lot of people involved in ultimately arriving at the requirement, because once it gets published, then automatically people start referring to it. So as much care is taken during the development stage. So it is established by means of consensus and is approved by a recognized standards certifying organization, and that provides for a common and repetitive use, rules, guidelines, or characteristics, which is ultimately aimed for an optimum degree of order in a given context. Now, this is very important. Now, this is where another important need of a standard is to set the safety and performance levels of the products that are covered by this standard. Now, fortunately, the product level standards provide a very unique advantage, as this helps to bring all the stakeholders, be it a designer, manufacturer, specifier, regulator, all of them can be on the same page. The number of ambiguities can really reduce when you have a product specific standard. Imagine a situation that you did not have a standard for busways. Then probably each designer will have their own way of describing safety. Each installer will have their own version of safety. So it is good to have product specific standards. Now, fortunately for the electrical industry, and at a very high level, we have two reputed and oldest standards development organization. They are the IEC, International Electrotechnical Commission, and UL. The International Electrotechnical Commission is an organization which spearheads the development of consensus-based international standards in the area of electrical, electronic, and related technologies. Similarly, Underwriters Laboratories, more than a century-old company, also develops standards that include safety standards for electrical and various other product categories to meet the North American market and aligns with the National Electrical Code requirement. Additionally, the UL standards are also trinational standards that mostly cover the requirements of USA, Canada, Mexico, Colombia. In addition to that, UL also actively participates in many of the IEC standards, including the 61439 series, and significantly contributes to the harmonization and adoption of these standards. Now for the subject of this webinar, we will focus only on the IEC standards. Let's now look at the development of the IEC standards. Now, why is it important? It's very important because, especially for regulators, it is important because we all know every country has some small uniqueness in terms of ambient condition or in terms of end usage. Now, the way the standards are set up is there is a national committee which is primarily represented by each country. So remember, when I say each country, Malaysia can have a national committee, India can have a national committee, Germany can have a national committee, Philippines can have a national committee. So those committees represent these in the IEC in the IEC standards making organization, and will have an opportunity to review the requirement before it is finally published. This is also a good opportunity because this type of meetings will enable what is going to come in future, what requirement that could be aligned is all discussed at this level. Now, having said that, the international product standards, essentially once these standards actually become an international IEC standard, you will find that they reflect the agreements on the technical description of the characteristics to be fulfilled by the product in question. And once an international standard is published, they're very widely adopted at the regional and national level and are applied by all the stakeholders. That includes designers, manufacturers, trade organizations, consumers, testing laboratories, government organizations, regulators, and any interested parties. So as you can see here, by the various committee representation, so we have the IEC standard. Subsequently, based on the IEC standard, the individual harmonization happens. So at the next level, you can have either a national level standard or you could have a group standard. For example, there could be many countries within the Europe, country A, B, C. For example, this could be Germany, Denmark, Netherlands. There are many countries which form an European Union, and they might decide to have a regional standard, also called as HEAN harmonized standards. Now, those standards are called regional standards. Then you can have national standards, as you can see here. So you have, especially for the IEC 61439 series, we have many countries who have harmonized or adopted to this standard. For example, Australian standards have adopted, Indian standards have started adopting, we have China adopting. So this is an example of how the standards get developed. Let me show you one real case example, especially with the 61439 series. Now at the high end, the IEC published the 61439-6 with the inputs of all the national committee members. And then we had this particular standard published. Subsequently, after the 61439-6 was published, then we had the group standard called the SINELEC. It is called EN61439-6. Remember, the difference between the IEC 61439-6 and the rest of these standards, what you see here, is the respective national deviations. For example, EN61439-6 may have certain national deviations that could be applicable for within Europe. Similarly, the Australia and New Zealand have also harmonized their national standard with the 61439-6, but then it has come out with a separate naming convention. That is because there is probably a couple of national differences that are applicable primarily for Australia and New Zealand. Similarly, China has harmonized its busway standard with IEC 61439 and does contain a couple of national deviation. So the IEC 61439-6 is so much popular standard, more than 40 countries across the world have either adopted them or they would have used them as it is in order to specify the requirement for busways. Let's now look at what important standards plays in a compliance system. So I've already briefed you what a compliance system consists of. You saw that there were three elements. One was the compliance itself, then you had the standards and technical requirement, and finally you had the enforcement, which is coming from the regulators. Now let's look at how the standards are so important and why the necessary importance has to be paid by one and all to understand what the standard intends and what does it specify. To start with, an end user or a contractor or a large buyer or a building owner who wants the electrical products to be installed, let's take busways in this case, how does he refer or how is he made to use the standard? Now it all starts with the specifiers or the consultants or the regulators indicating or specifying these products must comply to an international standard or to a national standard. So in this case, the specifier or a consultant very clearly specifies the busways and the busway accessories like the bends, the plugging units, whatever, all the related accessories, they will mention in their specification that these products must be in compliance to a particular IEC standard. Now, how does it get specified? It could be specified in a sort of a specification, or it could be a part of an electrical code, which is very prevalent in Europe and North America. Then you have, once it goes into a specification, then the supplier of that particular electrical equipment, for example, in this case, the assembly or a busway manufacturer, he is bound to demonstrate how those products are actually meeting the specified standard. So one way of demonstration is having those products tested and getting the applicable certificates or a certification mark to prove compliance that the product actually met the requirement. So what the assembly manufacturer or the OEM typically does is they would consult a certification organization. Note that there are two components in a certification. One is certification, the other one is testing. The difference is certification organizations typically operate under a system standard called ISO 17065, and all testing labs typically operate under a standard called 17025. So at a hierarchy level, a certification organization, which is the one which gives certificates after testing, typically testing could be done at different locations. It could be a manufacturer's location, it could be at a third-party lab, or it could be certification organization's own lab. So you sort of have a flexibility in where you perform the test as long as it meets certain requirement. Now the common factor with all these, starting from the end user, the regulator or consultant, the assembly manufacturer, or the testing organization, the common factor is the standard. So that will give you an idea the importance and role of the standard in a compliance system. And finally, when the assembly manufacturer contacts the testing lab or a certification lab, there is an output which is nothing but a type test report or a certificate, or some countries require a third-party safety certification mark. In this case, as you can see, it could be a UL classified mark. So this is how the standards are like a touch point at every location. A contractor or a user need to know, an assembly or a busway manufacturer or a designer who is making this busway need to know, because when he submits to the test lab, he has to ensure that he doesn't get a non-compliant results, because that would lead to a rework. A specifier must be aware which standards to specify, what is the addition, if there is any additional requirement they need. They also need to know whether it will suffice to have just a type test certificate, or they would also like to see a safety certification mark on the product, which will have a factory inspection. So the decision to which compliance to go is decided by the regulator. Okay, so let's now move on to our second module, which is the overview of IEC standards for low voltage switchgear and control gear assemblies. We will focus on the general rule standard, and we will also talk about the bus bar trunking systems. Now, before I go into these two standards, it is important for us to understand the series of standards that are available under the 61439. Now, as you can see here, this is a snapshot of the 61439 series and the associated standards. The first two standards are not necessarily product standards. The first standard is also called as a guide. It is mainly for the people who are specifying assemblies used by the consultants, could be used by regulators. It could also be used by testing houses, manufacturers. So primarily it sets out what and all you need to specify. For example, if you are specifying a busway, would you like the busway and accessories also be tested? Because many times what normally happens is only the straight length and the joint gets tested. Unless you specify, I also need the elbows tested, I also need the flanges tested, more likely the testing may not happen on those. So the specifier, that is one example. Another example is the specifier might say, I want the busways to be tested at an ambient condition of 50 degrees. This is very common for the Middle East market, because the ambient condition in those regions is very high. So they use the standard. In addition to the normal condition of the standard, they would specify higher ambient suitability for those products. The second most important standard in this series is the 61439-1, which is essentially general rules. So you might be wondering, what is this general rules? Now, as you can see, the 61439 series consists for many different product categories. For example, for the panel boards, switch boards, MDBs, the part 2 is used. The title of the standard is Power Switchgear and Control Gear Assemblies, in short. And then you have the standard for distribution boards, which is more likely for a skilled people used in the buildings. Then you have standard for assemblies for construction sites, standard for assemblies for power distribution in public networks like the feeder pillars. Then you have the bus bar trunking systems. So you have the power factor correction banks. All these standards in one way or the other have some general requirement. When I say general requirement, it could be the rated voltage, it could be the rated current, it could be the frequency, it could be the impulse voltage, it could be the clearance and creepage values, it could be some of the construction similarities, because they're all electrical equipment, they're all assemblies of low voltage and switchgear and control gear components. What the IEC did was, they have tried to group all the common requirement into one common standard called 61439-1. However, you need to note, we can't certify a product to 61439-1 because it is not a product standard. So if you have a busway, then from this context, you will need two standards to be referred. One is 61439-6, that is the product standard, also called a specific part standard. And then you will also need general rule standard, because that is where all your general requirements are actually specified. So these couple of standards I showed you, all of them will refer, depending on the context, back to general rule standard. So that is just an example I wanted to share. Let's now move forward how to apply the standard. Now that we know for any product like a distribution boards or for a panel board or for a busway, you're essentially needed to refer to two standards, that is the part 1 and the specific part. We need to understand how they could be applied. Now, for each type of switchgear and control gear assemblies, there are two main standards that are necessary to order to apply all the requirement and to also ensure the corresponding methods of verification. So the start with, so we need the basic or the general rule standard, which I would call it as a part 1 standard. Then you need, in this case, if we talk about the bus trunking system, you need the specific assembly standard or the part 6. So you need both of them. Now in the next situation, once you know that you need both the standards, general rules, and the specific part standards, also very important is which edition you need to choose. Now this is a very important understanding needed, especially for regulators, consultants. Now the 61439-6 currently is in edition 1, published in 2012. Now this actually came into effect earlier. There was a standard called IEC61439-2, and that has been superseded by the 61439-6 series. Similarly, for the general rule standard, you can see that there has been right now 3 editions. So the first edition of 61439 came in 2009. Subsequently, we had 2011, and then we now have an edition 3, 2020. Now, in the previous slide, I told you, you need to use the specific part standard, and also you need to use the 61439-1 standard. Now, the question then comes, which edition you need to use? So for 61439-6, edition 1, should you use edition 1 of part 1, or edition 2 of part 1, or edition 3 of part 1? So where do we get this answer? That's number 1. The second question is, when there are many standards that are used, when they are published, which one are you supposed to use? The ideal way is to use the most current version. In this case, the current version as of now is 2012 version for part 6, that is busways. Now let's understand which of the part 1 edition we need to use when it comes to 61439-6 application. Now it is very easy. When you go to the specific part standard, in this case, when you go to the normative references in 61439-6, it very clearly specifies which edition you are supposed to use. So this clearly specifies for a 2012 version of 61439-6, you are supposed to refer to the 61439-1 2011. Even though there is an updated version, which is a 2020 version, you are not supposed to use that unless that gets reflected in your specific part standard. So in summary, the specific part 1 standard edition that has to be used is actually brought out in the specific part standard. So I hope you understood how to apply the specific edition and also how to refer to the specific part 1 edition as well. Let's now also understand further how to refer back and forth between part 1, that is the general rule standard, and the specific part, which is the busway standard. So it's very important that many times you're supposed to interact with both these standards, and I will share with you few examples how that happens. Now, when should you really go to part 1? You always start with part 6, that is the specific product standard for the bus bar trunking system. Now, when the specific part standard refers to the general rule standard, only then you are supposed to apply those requirements. So let me give you a few examples. If you go through 61439-6, in clause 5, it is actually interface characteristics, and it states this clause of part 1 is applicable except as follows, which means to say you will have to go to part 1, apply in totality, and then also make this replacement. So it says, so you need to replace the general statement there and it says the characteristics of the bus bar trunking system shall ensure compatibility with the ratings of the circuits to which it is connected and the installation conditions, and shall be declared by the BTS manufacturer. So this is a replacement. So you need to replace this clause from part 1 and use it while you apply the standard. So one more example. If you go to 61439-6 and if you go to a specific clause 10.10.2.3.2, the subject title is test conductors. So the -6 does not contain any information about the test conductors. What it does is it sends us back to part 1. It says subclause 10.10.2.3.2 of part 1 applies. So this is what you will do. When you go to the test conductors, there is no information in -6, but then it says you need to apply this particular information from part 1. So this is how you typically start referencing back and forth. I hope this gave you a good overview of how to use, how to navigate between the general rules and then navigate the specific part standards. Now let's look at the content, have an overview of these two standards. Now, fortunately, the entire 61439 series follow the very similar structure. As you can see, every IEC standard does have a scope. Then you have a normative references. Normative means mandatory, which means to say I will subsequently show you a couple of information. So it will specify what other standards have to be mandatorily referenced when you use each of these standards. Then you have the terms and definitions, symbols and abbreviations, the interface characteristics. This is very important. Most of the times, the different part standards give more information about interface characteristics, which could be a replacement to what has been detailed in the general rule standard. Then the normal information that has to be provided by the manufacturer or to be used by the end user is mentioned in clause 6. Then you have the service conditions. The most critical thing for any designer, regulator, testing organization is these three clauses, clause 8, 9, and 10. Now, clause 8 and 9 are essentially ways and means to prove that your product has been complying to this standard. Now, they talk about a construction requirement, and then clause 9 talks about the performance requirement, and finally, to combine to meet the construction and performance, there is a certain amount of verification that one has to do, and this has been brought down under the clause 10, which is the design verification. And that's the reason why I have highlighted here, because if you understand the design verification, probably you would have understood most of the compliance requirement in those particular standard. And then you have the routine verification. So you might ask where this routine verification is used. Routine verification is used by the manufacturers themselves. For example, every busway that is shipped out, you might conduct an insulation resistance test, or you might conduct a very short duration dielectric test, or you might do some physical checks. It is also used by third-party labs when they give a third-party certification mark. They may want to do certain routine verification before the products are shipped out. They may also be used by the regulators to ensure every product that gets manufactured and before it is shipped, you do some sort of a pre-qualification non-destructive test. And finally, you have the annexures that are detailed out in both of these standards. Let's spend some time on the different annexures that are there in these two standards. Note that there are separate annexures in -1 and separate annexures in -6. Now in -1, you have many annexures. Let me brief you some of the very important annexures, probably that would be helpful for designers, regulators, manufacturers, and the testing houses. And also see the word here. You will find something called normative. Normative means if I have to apply this standard, I need this mandatorily, I need to use this. If I have to do a testing, then quite naturally, I need to know what is the cross section of copper conductors that I have to select based on the rating of the busway the manufacturer has declared. So without this information, I would be unable to choose the right cross section for my testing purpose. So that is why this is mandatory, or I would say considered as normative. Then you have another normative section. There is a method for calculating the cross-sectional area of protective conductors. Now this is again mandatory in terms of constructional requirement. Then finally you have a couple of informative sections. Now the reason that this is being made informative is every user can actually have different way of defining things. For example, they may want a different short circuit level, they may want a different IP rating, they may want a different fire rating. So in that context, so you will notice that this has been made informative in this case. Similarly, you will also find informative for the design verification. This is a very valid point that people ask, why is this design verification made informative and not normative? That is again because suppose you want to comply to a standard, you have got various means to comply. You could probably do all by testing, or sometimes you could also prove by means of a reference design, or sometimes you as a regulator could choose, I only want a short circuit, I only want to use a temperature rise for my determination. So that is why this has been made informative. Similarly, diversity factor, the manufacturers could use depending on what diversity factor they want. Then we run across many of the normative requirement, which is mandatory. So in order to meet this standard, mandatorily you will have to make sure the clearance and creepage distances meet the requirements in the standard. And then you have mandatorily you need to declare the impulse value depending on your need, and then the testing is performed accordingly, and that's why this is made normative. Normative means mandatory, informative means you have certain flexibility to choose depending on your need. Similarly, for part 6 standard, there are a couple of informative as you can see from here. So the one is the informative in context of the specification. As you can see here, the specification schedule, both looks very similar, except that this is more related to busways, whereas this is more of a general rule application for all the switchgear assemblies, switchgear and control gear assemblies. Then you have the Annex D, more specifically brought out for busways, which is slightly different from what you find in the Part 1 standard. Then you have a couple of other annexures which are essentially informative: the voltage drop of the system, the phase conductor characteristics, the fault loop zero sequence impedance. The reason this is informative is the end user will dictate if they want to have any of these verification needed for their busways. Let's look at a couple of more annexes. As you can see here, the Annex H is again informative because it talks about the operating current and power loss of conductors. But then Annex J is made normative. The reason why it is made normative is if you have to comply with your busways, and if your busways has any sort of an electronic component, example, you have a electronic molded case circuit breaker, then that particular molded circuit breaker should have already complied with EMC, or there would be a requirement for EMC testing, without which you can't claim compliance to the 61439 series. Similarly, when you go to the Part 6 standard, you got again informative requirement. One is the fault loop resistance and reactance, and then you have the magnetic field determination. Annex Part 1 has a couple of more annexes. One is protection by electrical separation, which is mandatory, and you also have a couple of more informative: clearance and creepage for North America region. You might be wondering, why did this specific requirement for North American region come here? As I was mentioning in a couple of slides earlier, both UL and IEC are in the process of harmonizing wherever possible. The best way is to start off somewhere, and one way is to start including a couple of informative annexures so that manufacturers, designers know what are the differences in the North American system. So this annex provides some of the clearance and creepage distances that are required for any product that are supposed to be used in North American region. This does not mean this product will be suitable for North America, but it is a slow and steady first steps to start including the requirements of other region so that the end user, the manufacturer also gets a fair idea what are those differences in the North American context. So all of them are all informative because this particular standard IEC61439-6 cannot be used in North America because there are separate product standards for North America. Then you have two more normative. One is the operating current and power loss for the bare copper bars, and then you have the verification of short circuit withstand strengths of bus bar structures. Now this is made mandatory because if you ever want to skip a test but then you want to verify by means of a reference design, you have to use the methodology prescribed in this annex to prove compliance for the particular standard. Okay, so you had a fair idea about the different annex and what it meant by normative, what is meant by informative. Let's now look at the scope of 61439-6, which is the primary standard for today's discussion. Now pretty much the standard has laid down very nicely about the definition, what is a busway, what are the different constituents of a busway, all those are pretty much defined. Then you have service conditions laid out. It also gives constructional requirements, which we will discuss in a couple of slides later. Then you have the performance requirement. Most importantly, the technical characteristics, which is very important for anybody who is going to specify. And then you have the verification requirements for bus trunk system. The most important thing is the framework within which this standard talks. So any bus duct that its rated voltage, which will not exceed 1000 volts AC, nor will it exceed 1500 volts DC, can all be covered under this standard, including all the accessories. For example, a busway with a plug-in system, elbow, joints, flanges, all the accessories that are related to the bus trunking system, they could be covered under this standard. Note that there is no mention on current rating, which essentially means that you can actually design as much as possible depending on the need. We have seen busways as high as 6000 amperes, sometimes going up to 7000 amperes, and also very small ratings, maybe few hundred amperes. So there is no framework or a limitation on the current capacity as long as you're able to design the bus bars to this requirement. The intended use is very clear. This has got a very broad scope. Any busways that are used in generation, transmission, distribution, conversion, or control of electric energy, all of those busways can ideally be covered under this Part 6 standard. Now let's look at some of the additional bus trunking system which are slightly different in the normal context. I would call them those that are used under special service conditions. For example, bus trunking systems used in ships, rail vehicles, or in some cases domestic applications, which are nothing but sometimes used by unskilled persons. In those cases, this standard would still apply, but then you need to remember this standard alone will not suffice. There is a need to apply supplementary requirement. For example, the supplementary requirements stated in 60092-302 should be additionally applied if these busways are supposed to be used in ships. Similarly, if the busways are designed for machinery applications, for example, there is a big machine and the busways are part of the machine, in such cases, then in addition to the 61439-6, the supplementary requirements of 60204 has to be applied to ensure compliance. The 61439-6 applies to all of the bus trunking systems which I told you in the previous slide, which are either designed or manufactured on a one-off basis or actually been fully standardized depending on the need basis. There are certain specific busway systems which are out of scope for this standard. For example, the supply track systems, the ones people use for lighting and such similar applications, they are not covered by this standard. You will have to apply 60570. cable trunking and ducting systems. So in such cases, you need to have a 61084, and power track systems, we will need to apply 61534 series. So this is clearly out of scope for such type of construction. Now let's look at the design verification. We have gone through what is the overview. We have gone through what are the various requirements and annexes. Let's now quickly talk about what really is about the design verification and what are the key parameters that you need to keep in mind. Now, for a design verification, there are very broadly you can classify. One is the electrical system, which is the key. Like when I talk about electric system, you need to know what is the rated voltage under which this busways are going to be used. You need to know what is the rated current that this busways has to carry. You need to know the frequency, whether it is 50 hertz or 60 hertz. You need to know the earthing systems, whether it is a TN or a TT. Based on that, you will decide to give your earth bar accordingly. Then you need to also know what is the external conductor connection or so-called field conductor. Is going to be meant for bus bar, or it is also meant for bus bar and conductor, cables, or is it only for cables? So that has to be decided, and this is one of the key attribute both for the specifier, also for the manufacturer, also for the test lab to determine the test lab. In addition to the electrical system, you also need something related to the environment under which the busways operate. Now you need to understand whether the busways are supposed to be used indoor or outdoor. Then you need to specify what is the IP rating that are required, what is the IK rating, then what is the ambient temperature requirement. Is whatever the standard says, is it enough, or you would like to have some special ambient conditions like 50 degree for Middle East. And most importantly, for the busways, the orientation also has to be specified, whether it is going to be used in a horizontal orientation, or it is also meant to be used in a vertical orientation. That is because we all know when we perform the temperature test, the busways by default would be tested in a horizontal orientation unless the manufacturer also wants to declare the vertical orientation as well. And finally, because bus bar trunking systems actually pass from one room to another room, one building to another building, and if in case of any fire, there is a high risk of the fire being transmitted from one building to another building, one room to another room. So depending on that context, there is a fire ratings that has to be specified by the end user, and there are two basic ratings. One is resistance to flame propagation, that is how quickly the flame gets propagated. The second rating is related to fire resistance. Now these are the key factors that will be used by the test lab, by the manufacturer, by the end user cohesively to determine what type of busway one wants and how ultimately it is going to be evaluated. I also will touch upon this. We already saw this. This is exactly the same thing which I talked. Essentially, you have the electrical supply system, then you have the environmental ratings, and then finally you have the fire resistance ratings. Let's spend some time on the different voltages that are applicable for any busway system. Now you have the rated voltage of the assembly. Now whenever you have a plug-in unit, it is possible that your busways overall rating of the assembly, overall rating of the busway could be 1000 volts, and your plug-in circuit can be rated at 600 volts. This is what we mean by you can have different circuits can have a different operation voltage. The overall busway can be rated for a higher value if you so require, or alternatively, the overall rating can still be 690 volts and your circuit operational voltage can also be 690 volts, depending on your situation. Then you have a rated insulation voltage, which is also called UI, which is very important for us to perform dielectric test. Then rated impulse voltage, this is also called, typically depending on where the installation happens, all these ratings has to be declared by the manufacturer in consultation with the specifier. let's look at the current ratings. As you can see, there are a couple of different current ratings. The most common is the rated current of the entire assembly, which is your rated current of the busway. For example, it could be 1000 amps busway, and that could be your INA. Now, if this busway has a plug-in unit and which has got a 600 amps breaker, then that particular circuit, you can declare that as a 600 amps. So in that context, it becomes the rated current of a circuit of an assembly, also called as INC. Now, after these two circuits, then you have something called the short circuit current ratings, which essentially has two different contexts. One is called the ICW, which is always associated with a time. So rated short time withstand current. So there is a time associated. So this could be like 50 kA for 1 second, 50 kA for 3 seconds, 50 kA for 2 seconds. So it is always associated with a time. Then you have, and quite naturally, when you have a short time withstand current, there is always a peak associated, because the RMS value will have an initial peak, and that is called the rated peak withstand current. While the rated peak withstand current actually comes from the standard, the rated withstand current can be declared by the manufacturer in consultation with the consultant or the end user. Now, there is another important short circuit rating called the rated conditional short circuit current of an assembly. This is always applicable when you have a protective device. So in the example I told you, when you have a plug-in breaker, for that circuit, we have a rated conditional short circuit of an assembly, which is primarily dependent on your protective device. So it could be like a 25 kA or a 50 kA. Note that there is no relation with the time, because the protective circuit is supposed to operate without waiting for any time duration. So that's the reason this does not come with time. This is always associated with the time. Few other ratings which we already gone through, but one thing I would like to highlight here is about the mounting orientation, more specific for busways. As you can see here, unless otherwise, this is very important both for end users, manufacturers, regulators. The busways are typically tested only in horizontal orientation, unless the manufacturer also declares their busways is also intended for vertical orientation. We have seen that when you do in a vertical orientation, the temperature rise observed is more than compared to a horizontal orientation. So just because the sample has passed the orientation in horizontal position does not mean it is okay, that limits will still be within the limits in the vertical. So you still need to do another test, certain tests like temperature rise, to prove that this particular busways can also be used in a vertical orientation. Couple of other things to keep in mind is the location of tap-off units, whether it is above the bus or the below, then the position of whether it is a flat wise or a edge wise. Also very important is to make sure, because many of these are the weakest link in a busway system. For example, could we have elbows, T's, flanges, right? So unless you have all of them tested, if you're using any of the untested elbows or T's, then it's quite possible that the whole product safety could get compromised. So that's something to bear in mind. About short circuit, I already discussed about this. Short time withstand always is associated with the time. Okay, let me quickly touch upon the design verification about the ambient conditions. So let me go through the couple of slides here. Okay, now I want to give you an overview now, having understood what are the different contexts that you need to look at. Now, if you look at this particular Annex D overview, this first part, strength of materials and parts, are essentially more related and are very generic to all type of busways. For example, resistance to corrosion. Now, if you really see the resistance to corrosion, you will find that these are primarily intended for all the ferrous metallic parts. So most of the busways will have a metallic enclosures. So then you need to make sure those ferrous metallic parts don't corrode over time, and that is why this test has been introduced. So it could be like, again, we have two classifications. One is an indoor use, the other one is outdoor. So if it is for an indoor application, we will perform a severity A test, and if it is for outdoor, we conduct severity B. Then for all of the insulating materials that are used in your busways, then we will have to perform a couple of tests. So what are those tests? So we have a thermal stability, then we have the resistance to abnormal heat and fire, then the UV test. So these three tests essentially are for all of the insulating material, depending on whether it is being used indoor or outdoor. Now the first one is thermal stability. If you have an enclosure, and then you will notice that the enclosure has a polymeric part, or a part of the enclosure is made up of polymeric material, then you will have to perform the thermal stability test. Then let's look at the abnormal heat and fire, also called as glow wire test. Now this test is typically performed at 960 degree or 850 or 650, depending on the specific use of the polymer material in the present application, in the context of the usage. The UV test is typically done for enclosures which are intended for outdoor use if it is made up of polymeric material, or if it is coated with any of the polymeric material. Lifting would be applicable if there are any lifting means. Mechanical impact would be applied when an IK rating is declared. Marking test would be applied depending on what type of marking mechanism the manufacturer has used. Then there is a test called ability to withstand mechanical loads, which is done for a straight length and on joint. The thermal cycling test is applicable only when you have a busway with a plug-in unit. Otherwise, this may not be applicable. Then we will have a quick overview of the other test. Then you have the degree of protection of enclosures. This is a very important subject. The reason being, the IP is determining your ability to use and also the ability to provide protection against ingress of dust or water. So that is determined based on what manufacturer declares. Then we have the clearance and creepage distances. This is basically again determined based on the insulation voltage the manufacturer declares, the impulse voltage the manufacturer declares, the material group of the insulating material that's been used, and by default the pollution degree is taken as 3 for this determination. Then you have the test for electric shock and integrity of protective circuits. We basically have two tests. One is to find out the effective continuity. There the resistance shall not exceed 0.1 ohms. Then we also have another test wherein we need to do a short circuit withstand test or withstand strength test of the protective circuit, depending on what the manufacturer declares for. These three highlighted ones, they are not test, but they're essentially construction and factory oriented verification, where you are supposed to ensure you are using the certified component, you are making sure that the electrical circuits or connections are designed properly, you have the conduct terminals properly designed to ensure that there is no problem associated during the field situation. So I will now go to the final slide, which provides to you the overview. Here we talk about the dielectric properties. We will talk more about all these tests in our subsequent two-part series, but I just want to give you some highlight on how this actually maps it out in terms of the characteristics that are to be verified. So with this, probably because of the constraint in the time, I would now go to summarize what we learned with today's webinar. So you basically had a good understanding of the importance and the development of standards and its relation to the compliance system. Then we also provide you an overview of IEC 61439-1 and part 6. So I would now hand over to Patrick for questions.
Thank you, CK. Okay. Thank you, CK. Thank you, CK, for the wealth of knowledge that you share with the attendees. At this time, we'll answer the questions that we received from the attendees. One question we received from the attendee: what are selection criteria for glow wire tests, and is there any sequence required for conducting the type test? CK?
Thank you, Patrick, and thank you for the participants asking this question. So glow wire, this is a very important question, because glow wire is one such test. That's something we could always do it upfront. Now, the criteria of selecting for glow wire: number one, for any insulating material that is a part of the busways, or any insulating material that is part of an enclosure, they're all supposed to undergo the glow wire test. Now, this it might help for you to understand the context of this test, because the insulating materials are bound to catch fire when they are in close proximity to electrical parts. So that is why this test was introduced, and as the name itself suggests, it is a test to abnormal heat and fire. We're going to verify, in case of an abnormal heat, whether it is going to contribute to any fire. Now, what are those relation to which we select? The test is made either on parts of the assembly. For example, if there's a busway, we could take a part directly and subject it, but because most of the times the busways are typically large in nature, and because of the glow wire setup is a bit small, the standard also permits that these tests could be conducted on parts taken from this assembly, which means to say I could choose a specific insulating material cut from the original product and then be subjected. So this is what most of the times we perform, and we basically have three temperatures. One is 960 degrees. This is for all insulating materials which are actually retaining current carrying parts. Then 850 degrees centigrade glow wire temperature for components or enclosures intended for mounting in hollow walls, and for all other parts we have to do it at 650 degrees centigrade. So I hope I answered the question. Over to Patrick.
Thank you, CK. Thank you for clarifying on the criteria for glow wire testing. We have another question from one attendee. Mentioned that in the slides you mentioned that some annex are informative while some are normative. They would like to know what's the difference. CK, please. Thanks.
Thank you, Patrick, and thank you for the participant for bringing up this question. Remember, in the couple of slides I showed, there were many annexes which were normative, and then there were some annexes which are informative. Couple of examples could be like the informative. Let me give an example, like the user information was indicated as informative. What this means is, informative is something that is basically determined between the user and the specifier. So they can always choose what to specify, what to include, what to exclude. So that sort of a empowerment is made by the standard to the user of the standard. Now, when it comes to normative means mandatory requirement. So if the moment the particular section is made mandatory, there is no way to sort of leave those requirements. Couple of normative requirements would be the value of clearance and creepage. So that is a normative. So you can't have a different value less than what has been stated in the standard. So that's a normative annex. A couple of other informative was your phase conductor characteristics for busways. That is again optional. If some end users want, they may want to have it tested. If somebody doesn't want, they need not test them. So I hope that sort of clarifies the question. Over to Patrick.
Thank you, CK. Thank you for covering the annex requirements. We have some more time. There's one more questions from the floor. Are there any critical component requirements like circuit breakers when used in Busway? CK?
Thank you, Patrick, and thank you for the participant for this question. We really discussed when we looked at the standard at a very high level. We had a couple of requirements. One was the construction, one was the performance. Now, when it comes to the construction, we typically end up with the components. Like again, when you come to the components, you have metallic components, then you have polymeric components, then you have some bought-out components. When I say bought-out component, I'm straight away talking about circuit breakers or a relay or a fuse if it is a part of your busway. Even though most of the components could be bought out, but what I'm telling is critical component, critical bought-out component like circuit breakers, they have to be certified to the corresponding IEC standard. If you're using any such switching devices, the part 1, that is IEC61439, is also talking about this switching components when used in an assembly should be certified to the respective IEC component standards. Couple of IEC component standards are 60947-2 for molded case circuit breakers, 60947-3 for switches and switch disconnectors, 60947-4-1, that's for the contactors and motor starters. All of these critical components, the manufacturer should have some evidence to show that the components have been in compliance to the component standards. Over to Patrick.
Thank you, CK. Thank you for addressing the critical requirements for circuit breakers. This is the last question we have time for. We have some more questions from the participants, but I think we're running out of time. So for all those participants who have sent the questions over, we will address to you via email personally, individually, so that we make sure that all the questions are being answered. And once again, thank you, CK, for the informative presentation, and thank you for taking time to participate in today's webinar. As we close this program, I would like to highlight to you that a link to the recorded webinar will be sent via email to all those who registered to attend. At the same time, that there is a short survey for you participants to fill up so that we can serve you all better and seek improvement for our future webinars. We hope you enjoy our webinar, and we'd like to inform that the second webinar for IEC 61439-1 and -6 will be held on 13th of August at the same time from 2 p.m. to 3:15 p.m. GMT plus 8 hours time zone next Thursday. Hope you enjoy the webinar and find it insightful. Stay healthy and stay safe. Thank you, everyone.
Thank you, ladies and gentlemen. Thank you for your patient hearing.